So, in the last class, we studied about cyber physical systems if compared with a human body. So, for example, which is not a cyber physical system, but for example, if we take so just like a human body, we have eyes, which works as a sensor. Eyes see the cup, and then we have a brain. Brain decides how to move. That act as a controller, and then our muscles contract to grab the cup. This is how the actuators work. And our arm moves and picks up the cup. That's what plant is. So plant picks up the cup, which is our physical word. And yeah, what about feedback? Eyes continuously check if the cup is grasped correctly or not. So that's how feedback is generated. That's a relatable example you can take. We have taken the drone example. So let's move next. CPS is like an elephant. These peoples are blindfolded, and one which is touching the elephant ear is saying it's a fan. Someone saying it's a snake. Someone saying it's a rope. He's touching the tail. Uh, one is saying it's a wall. One is saying it's a tree. So yeah, our CPS is made up of small subsystems. It could be an electromechanical system, a control system, human computer interface, a communication network, or software system. It could be made up of multiple subsystems and form a cyber physical system. So next comes the development process. So to develop a cyber physical system, it's not a straight line system. Means it's a iterative system. What does a iterative system means? Like creating a model, then designing it, and then analyzing it. It's not a straight path. You can found problem during modeling, or once model is created you can found it during designing. So you have to move back and fix the problem. So modeling, model specify what the subsystem does, capture the dynamic behavior of the system. Model could be of three types: continuous, discrete, and hybrid. So let's see one by one. What does a continuous system looks like? So this is the physical system model engine. So for a engine, for example, we have a helicopter and this is its engine. We model it using differential equations because it changes over time. It's a continuous process. Like it attains some rpm at some given point of time. It initial it's 0, then it's some rpm, for example 12 rpm, then 200 rpm, 300 rpm. So it changes. So to model this physical system we use differential equation. We will see this later how it's made and all. Then there comes the hybrid system. Hybrid is a mix up of both discrete and continuous signal. You can see the synchronous digital logic. Like this is the chip. uh, there are some gates made up using logism. So yes, you can create the digital logic. It's a discrete system. Then comes the hybrid system. To model this we use automata, theory of automata. So yeah, there comes the design part. So we will study them in detail. So for example, if I take a autonomous drone example, first we model it, then design it, then analyze it, and it's not a straight process, it's a iterative process. You have to move one part backward if you find a error or problem in the first part. For example, modeling autonomous drone. It's simple. You create a mathematical or logical representation of drone. You design the controller and then you analyze it. So, talking about modeling of a drone, the real drone have thousand of wires. It has screws. It has some batteries. It have motors and sensors. So yeah, if it's a quadcopter, it has four motors, propellers, sensor. For example, we talked about camera, batteries. So if we model all of these, so it will be a complex thing if we have to design each and every screw or wire, etc. and all. So yeah, we don't design all the things and model all the things from scratch. We just reduce the parameters and view upon and look upon only those parameters which we need to work. So then comes the design part. For the drone, we design the controller using Simulink or whatever you say. If you are designing a drone model, you use CAD. This is the design phase, we design it. Then there comes the analysis part. So analysis, we test it. We test our model design. So what question we ask during analysis is your drone is stable? Second, does it crash? And third, is it fast enough? So yeah, analysis totally depends on you. Like for what specific purpose you want to design or model this drone. So we will see a development process of a helicopter in detail, and we will design a Simulink model for it. So we will get a clarity on this.